Okay, so my index of should take a string, it should take a value, and possibly a start index, right? Okay, so I'm just going to say function my index of, and then I will say string, and then I will say value, and then I will say start index, okay? Well, I'll just say start. So, this problem is a little tricky because the way you set the loop up is a little different than just incrementing something by 1 every time and stopping when you reach the end of the sentence. Okay? So, if you guys knew this, dot index of is actually a string method. Okay? So you can like have a variable that's equal to a string. You could say like let string equal hello, and then you can console.log string dot index of and then type it and then pass in another string, right? And then here you will get the ease index in that string. What index of does is search through the string and look for where that certain thing you passed in, where the index is that it starts. It also you can do more than one, right? And it starts in the same place. Okay? You can also pass in a starting point. This is saying we're going to start this at the third index. So we're only going to start this at the L, and then we're going to look for ELL. But there is nothing at past that point that's ELL. So if it can't find anything, index of returns -1. So that's exactly what we're going to write here. Okay? Whoops. So, okay. So the first thing you have to do is, I already said one thing, right? That this is an optional parameter. So that means that the person who will use your function might not give in the start index. So if that start index is never actually put into your function, you're just supposed to start at 0. You're supposed to start at the beginning of the string. So there are two ways to handle this scenario, and you should do this first. Because you know that like your start index should probably be in your for loop what the I value would be, right? Where the loop will be starting. So you can't just set I equal to 0. You should set it equal to the start index, right? Because that's where they want you to start. But if it's undefined, we don't know where to start. So we can do a simple if start is equal to undefined, then we can say start equals 0. And it's that simple. That's the first thing that this function will do. It will check and see what the value of start is. If you don't pass in an argument to a function that's expecting one, this thing, start, if it's referred anywhere else, will be undefined. This variable will be undefined. So you can do this, or in ES6, ES next or whatever, you can do this. This is saying the same thing. When you define your function, when you're saying, okay, this is going to take a parameter that's going to be called string, the second thing they take is going to be value, and the third thing is going to be start. But if you say equals 0, this is saying that, okay, if they don't put this in, start is going to be 0. That's what this is saying, okay? So I will leave this part commented out, and I'll leave this in here, okay? So now we have to write our loop. So first things first, I always want you guys to do, if you guys are struggling with loops, just do this first, okay? Write out the foundation of the loop. For space, parentheses, space, 2 curly braces, and enter it down, okay? Because I saw a lot of you guys having 1 extra or 1 missing curly brace yesterday when you guys were working on the workshops, and those things could be really hard to debug, especially if you're new at programming. For me, it's not that bad, but like for you guys, it probably will be. So always start with the foundation, and all of your code in the for loop will go between these 2 braces, okay? So now, let's write our for loop. I already said in the beginning that we're not going to just say let I equals 0. We're going to say let I equals start. Whoops. Whoops. Right? That's where we should start. If they don't pass in a start index, what's it going to be? 0. Because that's what I'm saying here. Okay? So now, where do we stop? This part is tricky, right? Because, like I said, we can pass in 1 character, or we can pass in many characters. But let's say, if you're looking for, if you have a string that's like hello, and you're looking for L, but I'm telling you to start at 3, right? If I'm telling you to start at index 3, that's at this L, right? The second L. And there's only one other thing in the string. But I'm looking for something that's 3 characters. So there's absolutely no possible way that this could be the case. There's no possible way. So instead of actually going through the loop and checking, like, oh, is the next 3 characters? Because if you try to access, if this is a length of 3, and you're trying to access a length of 3 where there's actually 2, the third thing after the 0, if you try to access an index that's non-existent, it will just be undefined. Okay? So we can say that as long as I is less than or equal to the string dot length minus the value dot length. So we take the length of the string, which is 5, and we subtract the length of the value, which is 3. Because once we get to 2 and we check everything, there's no reason to increment again. Because there's not enough space to hold that. Does everyone understand that? That makes sense, right? Like if there's not enough characters in the string, just stop. You're done. The answer is -1. Okay? So, and then, like always, we can just do I++. Because we want to check at every single time. So now, we can say let substring, and I'm going to say substring because what I'm going to do now is take part of the string. I'm going to take part of the string, slice it off, and I'm going to check if that value is equal to the value we're looking at. And if you guys remember how .slice works, we can do string .slice, and we're going to start at I. The number you start at, the index you start at, will include that value. Okay? So wherever I is, wherever I is, will be where we're starting. So we'll start first at the start index, right? But then we want to know where to stop. So we can do I plus value dot length, right? Because we want to go and it's dot length and not dot length -1. I know that length and number of index and the last index numbers are off by 1, but we want to actually do value.length because the stop index in slice does not include the character at that index. Okay? So we'll stop there, and then we can just do a simple if statement. If substring is equal to value, what are we going to return? What does index of return? The first index where you find it, right? Let's say you're looking for L. It's not ELL, it's just L, right? We want the index of the first L in hello, not the second L, the first L. So, an easy way to do that is to just return I. Because once JavaScript hits a return keyword, it will stop the function, and then nothing else will happen, even if it's in a loop. Yeah. What? My bad. Thank you. Yeah, because then I would have finished the problem, then I would have ran it, and then I would have gotten mad because I didn't know what was going on. Thanks. So you check if that substring, like you take that substring off of the whole string, and you check it against what you're actually looking for. So if you do put in a character, we're only going to slice off one character every time. Because let's say you start at 0, and you're looking for one character, it's going to slice from the 0th index of a string of one character. At the 0th index, it just is that character, right? And then 0 plus the length of that string, which is 1. There's one character. So 0 plus 1 is 1. So 0 to 1 will give you just that character because it's not including index 1 of a string with one character inside. Because index 1 of a string of one character would be undefined. And then this thing will run and it will run until this for loop breaks, right? So if we never find it, we can just return -1. That's it. So now if we do my index of, and I pass in hello, and I'm looking for E, and I'm not going to pass anything in. Oh, I'll console log it, so you guys can see it in white instead of green. You get 1. The E is at the index 1. If you pass in hello, you get 1. Because this string, hello, starts at index 1. If you tell it to start at index 3, you get -1. If you pass in like, let's say start at 1, and you pass in an exclamation point, you get -1, because that doesn't exist. Okay? Not so bad, right? I don't want to spend too much time on these questions, so I'm just going to move on to the next one so we have more time for today's topic, which is coercion and truthiness. Sound good? Did that help? Cool. So, next problem. What was it? Most vowels. Most vowels. This one is also tricky. So let's say I'm going to just open up the problem, and I am going to copy this sentence. Okay, that is what they used. So, most vowels. So what this function, wait, let me just write the function out, number 1. So function most vowels I'm going to write this function differently. I'm going to say const most vowels is equal to this, this, this. This is another way to write a function, okay? Const is a lot like let, in a way that it tells JavaScript that you're declaring a variable. However, you know how we are constantly using let in for loops and we're just saying I is equal to I plus 1? You're reassigning I. If you set something to const, you can never reassign it, or else JavaScript will throw an error. Does that make sense? This is a constant, and it will not change. It will not be real. And I'm saying this constant, most vowels, is going to be equal to a function. And you could write a function with just open parentheses and close parentheses, and then an equal sign, greater than sign, which we call a fat arrow, okay? And then just open braces, and there's your function. So, let's look at this problem at a high level, right? We have this sentence, and the whole thing is one string. That means that this is one value. So it's kind of hard to get what is what, like what is what word, you know? So, we know that we have to go through the whole thing, right? We have to see each word, and we have to see how many vowels are in each word, and then we have to take what's the most of those and return that word, right? So there's two variables that I should be making right off the bat. I should be making current word, and I'll set that equal to a string, because this will be the current word, right? And then I will say let current count, and this will be 0, because before we start, there won't be any vowels. Then, what's another thing we could do is pretty much copy these exact same variables, except this will be the biggest count, and it will be the word with the most vowels. And the logic behind this would be, as you're looping through this one string, once you hit a space, you know that everything before that point was a word, right? So you record the word, you record how many vowels were in that word, and then you will check to see if that number of vowels is bigger than max count. So the first time you find one vowel, that will be true. And then if that is true, then you will say max word. Then you're going to just reassign max word. Does that logic make sense? Yeah.
Why do you set max count to 0?
Because if I'm looping through this sentence, right? And let's say I hit I, right? It's not a space. And then I hit the space. So you know everything before this was a letter, right? Was a word, right? So then you can look and see how many vowels were in this. There's one vowel, right? I is a vowel. So then you could just say count plus plus. You got 1. So the count will be 1. If you started at 1 and you add to that, you would get 2, but there's actually one value. You know? When you're incrementing by 1 every time, it's good to start at 0. Because you know before you even start doing anything, you have no vowels.
Why do you say let max count instead of let count equals 0?
You have the current count and the max count. The max count will be the thing that we are returning at the end. And this number will only change if this number is ever bigger than that at the end of a word. The current count will be for this, then that, then that, then that, then that, then that, then that. And then we'll check how many vowels are and record them in current count. And when we hit that space, we'll know we're done with the word. So then we can say, oh, okay, did that word's current count, is that count bigger than the max count we had before? And if it is, then max count will be the current count. And then once you get to the next word, current count will be 0 again, right? Because you have a new current word and a new current count. So then we'll count that up again, And then if that's bigger than the max count we found the last time, we'll change max count and the max word. But if it's not, then we just say forget it, keep going. Look at the next word. And then at the end, these two variables will have our saved values, our saved maximum values. Does that make a little sense? Let's write it in code, yeah? So, let's start with our for loop. So we know this is actually going to be, let me do the thing for you guys. So this is actually going to be a very simple, this takes a string, my bad. A very simple for loop, right? It's just you start at 0, you increment by 1 every time, and you go until the string is done. Nothing weird here yet, okay? So what some people like to do is take out the is to capture the current thing you're iterating through into a different variable and call that something that makes sense. So I actually just like doing like sent string of I, but I will make a new variable for you guys. So let current car equal string of I. Cool? So now we will do our logic. The first thing we want to do is, as we're looping, we want to check and make sure for two things. We want to check and see if the current character is a space or if it's the last character. Okay? Because you know if it's a space, the word ended. But you know if it's not a space, you can check and see if that character is a vowel. Okay? So you can say if current char, right, is not equal to space, which is just a regular string, and then tap the space bar. It looks like an empty string, but that's actually a valid, that has a character code, okay? That's a valid string. And you have to see if you are not at the last point, if I is not the last letter, okay? So I is not equal to string.length, -1. So if these things are true, we are going to say current word plus equals current car. So now our current word will be have that current character inside of it, you know? And this will keep happening until we hit a space. Then we have to check if this is a vowel, right? We have to check if this current character is a vowel. So there's two ways to do this, and I'm going to do it the way the solution told you how, to write a helper function. Helper functions are kind of smaller functions that you can use in bigger functions to save space in the bigger function. And you usually write a helper function if you know that you'll be doing that thing a lot, and it's like does one specific thing usually. So this specific thing is just going to check and see if this character is a vowel, you know? So let's write that down here. So function is vowel. And this is going to take a character, right? So is vowel, you can just say let vowels. You can do this in two ways. You can say let vowels is equal to A-E-I-O-U, A-E-I-O-U, or you can go through, you could just say lowercase A-E-I-O-U, and then turn whatever that character is into a lowercase before you check it. I'll leave it this way, though. Because these are all the known vowels to the English language, right? So then we could say if vowels dot index of car is greater than or equal to 0. Or you could say is equal to -1, right? And if it is equal to -1, we return false. Otherwise, if it's anything else, we can return true. So index of, you can dot off a string, right? You do that string, which is captured in vowels, dot index of, parentheses. And then we're going to pass in the thing we're looking for in vowels. So, and if it's any one of these things, it will return that index. And if that thing is not there, if it's like a K or an M or something else, we're going to get -1. False, it's not in there. If it is anything else other than -1, it's true. Yeah.
I'm not sure why we get -1.
Index of, if so, you have your string variable, right? And then you do dot index of. So when you do dot index of, that method index of knows that we're going to be looking through this string. Then whatever you pass into the parentheses is like a character or multiple characters. In this case, we're only going to pass in one character. What index of is doing for you behind the scenes is looping through this string and returning the index of the thing you passed in. It's looking for that index. But if it doesn't find it, like in A-E-I-O-U, A-E-I-O-U, if you pass in like an X, that's not in the string, so it's going to return -1. Because there is no index -1.
Why wouldn't it return 0?
Or false.
Because I did not write JavaScript and I don't know why. That's just how it is.
Alright.
Yeah, that's just kind of like, remember, if it's -1, it's always going to be -1 if it's not in the string. That's true. Okay? So here we have a small helper function that's going to take something, look for it in this vowel string, and then return if it's there or not. So now we can use that up here. So if is vowel of current car, right? So what this is doing, if you remember what I said yesterday, anything you put into an if statement, it will coerce it into a true or false statement. But in this case, we're returning true or false anyway, so we don't have to worry about that. So if this is a vowel, if this is true, we will say current count plus equals 1. We found one. Cool. But now, what if we did hit a space? Right? What if we did hit a space? So if we look into, let's ignore this I, right? Let's look at like this word sum. We're looping through, we check S. Is this a space or the last character? No. So we are going to, no, it's not, so it's just going to not go into that if statement, right? Then the loop will continue. Then it'll look at this O. Is this the, oh no, I mean, if it's not the space, then it'll go into this if statement. And then it will add the S to the current word, to the current word, right? So the S is now in the current word. Then it checks if it's a vowel. It's not a vowel, so this part doesn't run. And then the loop will continue. Then the O comes along. We put that into the current word because we need the whole word. So whatever it is, we're going to put it in the word. Because that's the thing that this function has to return, right? But the O is a vowel. It passes this if statement, so then we'll increment the count. We found one vowel. And we'll do that until we hit this space. We record the E, so now current word is sum and current count should be 2. So now what happens when we hit the space? So we can do an else statement, right? Else If it's not a space, then it's not the last character. Else, we can do if current count is greater than max count, if the word that we currently have, if its number of vowels is bigger than whatever the max was before. We started it at 0, so it will be greater the first time if we ever find a vowel. So then we say max count is going to be equal to current count. And then we say max word is going to be equal to current word. Because we also have to record the word because that's the thing we're returning, right? So now, this logic will only happen if the word we just finished going through has a higher vowel count, right? But even if it didn't, even if we hit the space and it was like it was something with one vowel and our max vowels was already 5, even if we finished, we have to delete the current word. We have to restart that, right? Because that's outside of the loop. And we have to restart this count, the current count, because that will always have to be an empty string at 0 when you're starting at each new word, right? So then outside of this if statement right here, we can do, not in an else, just regularly, we can do current word is going to be equal to this, and then current count is going to be 0. Then, outside of the for loop, we can just return max word. So if you run most vowels with test case, you get keeper. That function was a lot, but like it does what we want. So, I would love to scroll up just a little bit. Here.
Question. Why are you defining in the beginning you define current word, current count, and then at the end of that statement?
Here?
You're redefining it. Why is that?
I'm not redefining it, I'm reassigning.
Reassigning, sorry.
Reassigning. So the reason I'm reassigning is because when we hit this, right? When we hit that space, we want to look at what that current word, the current word at this point is with, and the current count will be 1, right? Because there's 1 I. So then we're done. We check. Well, we check and see if that's bigger than max count, and then we reassign it if we need to. Even if it's not, though, if it is, if it's not, when we're starting sum, current word is with. So we don't want to put this S into with to make withs. And we don't want to count this O and E to the already count of 1 with the I, right? So we just start the counter again, get rid of the word, new word. What's up?
So if we do for the scroll down, the string dot length is less or minus 1.
Yeah.
Doesn't that put off the last character if it's not if it's like a letter?
Oh, whoops. One, two, three, four, five, six, 7. 1, 2, 3, 4, 5, 6. Oh, it does. Whoops. Does that matter? Do I need that? Oh, I think this. Huh. So this. Wait a second. So we can say. So we can say. Right before this, we can say if I is equal to string dot length minus 1, if this is the last thing, we can do current word plus equals current car. Yeah, cool. Now the solution is right. Good catch. So the reason why we need to check, we need to cut it off over here. Why do we need to cut it off over here? Because let's say the word doesn't end with a space, right? I mean, let's say the sentence doesn't end with a space, because that's really all we're checking. But like the thing at the end, that's still going to be the end of the word, right? So then we can still go on to the next part and check if what we had. But I forgot that since this current count is in, this current word plus equals current car is inside of this if statement, we actually have to take care of that last letter over here. So right before we do the check, right before we do the check here, we will add that there. We will add on that last character. No matter what it is, and we know that it's not going to be a space. Wait, no, it would be a space. If this was a space at the end. What the fuck? Because I'm pretty sure if this is just like space. Yeah, it works out. Cool. No, I think I have to do this. And not... And current is not equal to space. Yeah. Okay. Yeah, so you check and see if it's the last character, and you check and see if it's not a space. Well, I mean, we're just going to assume that there isn't anything at the end of the sentence, but if you really wanted to be like really like make this a good function, you would check for special characters too. Because like if there's an exclamation point or a question mark or a period, that's not part of the word, right? But like we're not going to do that. You get it? On to coercion. If you guys aren't feeling like that comfortable about loops, don't worry about it, because you guys are going to have to use loops to solve almost every problem you'll ever face, ever. Okay? So like you will get used to them, and you will get good at them, and they will become like second nature. Okay? So if you really don't get it now, don't like panic about it, and like, oh, just relax. You'll be alright. So that was max count. And yeah, like I said, I'll be posting like a poll tomorrow. I don't know when I have time, and just like check it out and like the ones you hated the most, you could just do. And if you had no problem with anything, just like don't do anything, and then we could just spend more time on the day's topic and more time for the workshop, right? Cool. So here we will start coercion and end truthiness. So what should I talk about? So there are two types of coercion. And before I talk about coercion, let me explain to you what coercion is. Coercion is something that happens where you can change a value of one type into another type, where you can change a string into a number into a boolean, and whatever, you know? And there's two types of these coercions. There's explicit and implicit, okay? Explicit is where you yourself as a developer are saying, I am now going to do this, yada, yada, yada. But then there's implicit coercion that JavaScript does for you behind the scenes. And this is actually extremely useful. But it's not that straightforward. So you have to be aware of what exactly is happening so it doesn't mess up some of your code, you know? So let's talk about explicit first, right? Explicit. So there are these things called the global number object and the global string object, right? And that's just like capital string, capital number. There's even capital Boolean. Boolean is just true or false, right? And you can coerce things, like if you want to make 7 into a string, if you want to make a string of 8 into a number, and if you wanted to make 0 into a Boolean, I think I have to console log everything. So I could say let string equal that, let num equal that, let bool equal that, and then here I'll console.log type of string. And then here I could do type of num and num, and here I could do type of bool and bool, okay? So if you want to check a value's type, if you want to check a variable's type, you do type of, no space in between the type and of, and then a space, and then whatever's after it, it will tell you the type. So if we look here, we can see that this number 7 I put in is now a string, but the console still says 7. The string 8 I put in there is now a number. And the 0 I put in is false. Coercing things into Booleans is what I'm talking about when I say truthy and falsy. They're not the actual values, truth and false, but 0 is falsy because when you coerce it to a Boolean, it is false, okay? It is the value false if you coerce that number 0 into a Boolean. So you might be asking, what happens if I do A? Then you get this weird thing here, NaN, not a number, which weirdly has a type of number. Don't ask me why. I don't know the answer. But when you try to pass things and make them into a number that clearly aren't, like these are just characters, it's not going to coerce it because it just can't. It's just not a number, you know? Any questions on this? Yeah.
When you type string,
String.
right here, type of string.
Yeah, so this is one statement we're printing out, and then there's a comma, and then there's another statement. Does that look familiar to you? That's kind of like calling a function with two things. That's because log is a function, okay? And that function just prints out whatever it is in the terminal. And you can pass however many arguments as you want. So first it's console logging this statement, which is saying type of string, so you get that string. And then the next thing is the variable string. And that's when you get 7. that make sense? And these things, capital string, capital number, capital Boolean, those things are available to you at all times. Yeah.
Can you coerce anything outside of like the primitive types? Can you coerce like functions?
I've never tried to do that. Yes. Into a string. I think this will be true as well. Yes. Definitely can't do this into a number, though. I'm not even going to show you. But yes, you can. You can coerce anything into a Boolean. You can coerce objects and arrays into Booleans, which we'll cover next week. Don't worry about that. Okay? So now that you guys see this explicit, like you see, like I as a programmer am actually saying, okay, I'm going to put whatever's in here. This is going to be a number, right? That's what I'm saying. However, I'll just do that. However, if I say, then there's this implicit, right? Is that how you spell implicit? Probably. So then there's implicit. If I say console.log, this is better, right? You guys can see this, right? You in the back. Good? Cool. So if I say 20 plus 20, you get 40, right? But what if I did 20 plus 20? What am I going to get? Who thinks the number 40? Who thinks the string 40? Who thinks the string 2020? Oh, that's what it is. Because what JavaScript does, it says if you add anything to a string, it's going to coerce the other value into a string. And the same thing is true for like any value, right? Null is a value. You get null 20, and that's one string now. And the same thing happens. The same thing happens in reverse. You could do 10 plus 20 plus 30 plus 40. So what you will get is 60-40. Because it goes from left to right. At first it adds the 10 and the 20, then it takes what this is, and then it adds 30 to 30. Then it takes what that is, and then it adds 60 to a string 40. Then that's why you get 60-40. Any questions? Cool. Yeah.
Why does the 40 include in quotes or whatever that is?
It's a string.
But so then the 10 plus 20 plus 30, that's not?
Yeah, these are numbers. These are type of numbers, right?
But when you refer to 60-40 in that, you refer to the whole number as a string.
It is. Because what JavaScript does is it goes from left to right. It adds this number to this number. Because this is the first, because it sees this plus, right? And it adds this number to this number. It gets the value, which is the number 30, right? Type of number. Then it takes that type of number 30 and it sees this other plus sign, and then it adds it to the type of number 30. So you get the type of number 60. Then it takes that type of number 60, it sees this plus sign, and it adds it to the type of string 40. Then it has the 60 already, right? There's no more 10, 20, 30. It's just the 60 at this point. And then it coerces that thing into a string. Because if you try to add anything to a string, the other thing is going to get coerced into a string. Make sense? Cool? Okay. So this is like kind of like an introduction of like implicit coercion. Like these things can happen, okay? The same thing happens in if statements, you know, like if 10 console.log year. get the error, okay? Because 10 is truthy. It's not the value true, but it is truthy. Because if you did capital Boolean, put a 10 in there, you get true. Any number is coerced into true except 0. There are a few numbers that are coerced. There are a few values that are coerced into falsity. That will be null, undefined, 0, empty string, false, obviously. I feel like I'm missing one. Huh? Huh? Oh, not a number? Yeah, I straight up don't know. Yes. Okay, cool. And I think that's it. It says it in the slides. We'll see that later. So now that we're talking about implicit coercion, I want to talk to you guys about something else. Who thinks that this is true? It's not. Because the number 5 and the string 5 are two different types. They're two different values. Who thinks this is true? It is true. Because what the double sign does, what the double equal sign does, is it actually coerces the 5 to a string, the number 5 to a string. That's why I always tell you guys to just never use double equals, because you're gonna find like very little use cases where you would actually want 5 to equal string 5. When you're comparing things, you want them to be exactly the same, right? So just use triple equals to be safe. Because like you never know, you know? Like even like this double equals false is true. It's really weird. And then you get like 1 double equals true. But 2 doubles equal true is not true. It's weird. Okay? Let's see if this is right. Yeah.
So if you do triple equals something with any number, it would always come true.
No, this is false. Triple equals. Double equals 1 is. This is a true statement. What this is actually doing is it's coercing the Boolean true into a number.
Okay. But why would you just add 2 as well?
Yeah, but when you're double equaling a number to a Boolean, it coerces the Boolean into a number. That's what's happening behind the scenes. True is coerced into 1, and false is coerced into 0. Because think about it. Booleans have 2 values, right?
Didn't you just type 2 and it came out false?
I said true is coerced into 1.
Yeah.
2 is not equal to 1 in double or triples.
Okay.
So it's false.
Oh,
Does that make sense?
so
Yeah.
Where are you coercing true into 1?
I'm not. JavaScript is. That's what the double equal. It's weird. It's not like I'm telling it to do that. That's just what JavaScript is doing behind the scenes. I can't control that. That's part of the language. You don't really have to understand why these things are being coerced, like why false is being coerced to 0. That's just like, this is a true statement, but they're obviously not the same value, so just don't use double equals and use triple equals. That's like the main point of this. Cool? Okay. So then, oh yeah, so now I want to show you 2 other operators. It's the bang and the double bang. When I say bang, I mean exclamation point. If you say console.log bang true, you get false. If I wanted to do console log bang A, B, C, D, A, B, C, D, E, you get false. What one bang does is it takes what's after, turns that, like if it's a truthy value, right? A string is truthy. It turns, and then it reverses. It turns it into true, and then it reverses it to false. So what I like to think of one bang doing is like kind of like a reverse coercing it. I don't know. It's just like a reverse coercion into a boolean. You know? So like if you do bang null, you get true because it's opposite. This is just the opposite. And if you do double bang, this is just coercing it into the boolean it is. This is the same thing as doing this. Okay? It's the same thing. But bang bang is easier to write than boolean. And then if you want the opposite, you just do bang. Does that make sense? That's like pretty straightforward, right? This does this. Remember that. That's like a pure memorization thing. You know, some things are just you have to memorize them. Not everything is logic. Okay? Cool. And then quickly I will go over what quickly I will go over what the hell? This happened like the other day. I'll quickly go over like let what is this equal to 4 and 0. Console log what is this? Who thinks it's going to be 4? Who thinks it's going to be 0? Who thinks it's going to be true? No one said anything. Cool. It's actually 0. When you're writing this in if statements, you're going to say, like, if this is true and this is true, both of these things have to be true for this if statement to run. That's correct. However, this is actually going to return you the last true thing, the last truthy thing, or the first falsy thing that it sees. So it's actually returning a value. Yeah. Like if I did what is this is equal to this? If I did 5 and null and 0 and false, you get no. Because all of these things in a row, it finds the first thing that is falsy, which null is, and it's going to just return that. For and. If this was a string null, a string 0, and a 1, 2, 3, 4, 5 number, you would get 1, 2, 3, 4, 5. Because it returns the last truthy thing. And this kind of makes sense, right? Because what and is doing is like, this whole thing will be truthy if everything is truthy. So it has to check every single thing. You have to go through everything. And once it hits the last thing, if that thing is truthy too, it returns it. But if one thing is falsy, it's just going like to be like, everything's false. So just return this thing. And if that's how it is for and, then we could say, oh wait. You get 4. Because or will be the reverse of and. If you put the or symbols in the if statement, only one of those things has to be true. And it kind of makes sense, like, linguistically, right? Like, if this or this or this, just one of those things has to be true. It will return to you the first true thing. Because if this is true, screw everything else, it doesn't matter. You get the first thing. But if this is false, we're going to have to go through everything to make sure that there isn't one true thing. So if you make it to the end, it returns the last false thing. So now we will go into the slides. And just in case you missed anything I said, I'm going to say it all again right now. Okay? This isn't that bad, right? This isn't too complex. It's just a thing that happens and you have to be aware of it. Implicit coercion, okay? So we'll talk about types, explicit and implicit coercion, concatenation, the loose equality operator, and then coercion into Booleans, which is what truthiness is, okay? So you've already seen numbers and strings and Booleans, and these are all primitive types. There are also complex types like arrays and objects or functions, but we're not going to talk about that right now. And then other primitive types are null and undefined, and we're not going to talk about symbols at all. So complex or objects types, right, are functions and arrays and objects, and we'll cover those later. And the major differences between primitive and complex types is only complex types can be mutated. I'll talk about that next week. And primitive types are passed by value, while complex types are passed by reference. This will also, we will cover later, okay? And I don't want to go too far into this right now, but just know that there are major... Oh, is this okay for you guys over here? That it's off the screen like that? Okay. So explicit coercion. Coercion occurs when the type of a value is changed into a new type. Explicit coercion happens when we use one of built-in global objects to create a value of a new type. So you see, we set num equal to 10. We console log the type of num. You get number. Then we say let string equal to capital string, invoke it, and pass in the number. Then we can console log string. It looks like 10. It looks like the same thing in the console, right? But if you console log its type, it's a string. Any questions on that? Okay. And the same thing can be said with a number, right? String 1000, type of string, string. Let num equal number, pass in that string. You still get 1000, and it looks the same, but its type of is number. If you're using the capital number, you can only pass in strings that will actually evaluate to a valid integer. Okay, you can coerce like a string of 2.5 into a number, and it will be 2.5. Okay, I didn't show you that, but it's the same thing. That is a number, right? Cool. So implicit coercion also changes the type of value, but unlike explicit coercion, implicit coercion is something that JavaScript does for us behind the scenes. This behavior can be very helpful, but it's important to understand what is actually going to happen because it could mess up your functions. It could mess up your logic. So let's talk about the plus sign. And I showed you this. Oh, whoops. Whoops. So we say sum is equal to 10 plus 20. Those are two numbers. The answer was 30. Is 10 plus 20 30? Cool. So let the concatenated string is going to be 10 and 20. This is going to be a string 1, 0, 2, 0. And they're all going to be characters. Okay? That's what the concatenated string is. I showed you guys like concatenating strings when I did the most vowels problem, right? That's how we made the current word variable. We just added a character each time by concatenating the two strings. Let not sure equal 10 plus a string of 20. Will this throw an error or return a value? We see in the console log that it does return a value. But what type is it? It's a string. Because that's what the plus sign does. It's the same value as concatenating 10 and 20, but the plus operator will implicitly coerce a number to a string if you try to add it to a string. So this will be a string, and you see that the first thing is 10, and the next things are all numbers, but since the first thing is a string, that's what you get. Whereas, here, you don't get the same thing. Because the string is at the end, and we're starting at the beginning. So it does all of this math first, and then it adds the 50. It adds whatever that is to a string 50, so you get a string 10,050. Does that make sense? Cool. So avoid using the double equals operator because it uses a large set of rules to implicitly coerce values to make some types, implicitly coerce values to the same type before comparing them. So 10 equals 10, that's true. This is also true, and it makes sense, right? Because we saw that, like, if you try to add a string and a number, one of them will be coerced into a string. Same thing here. But a string of true is double equal to the actual Boolean value true is false, which is something that you might expect, but you might have like thought this would be true, but it's not. Empty string is double equals to false, and true is double equal to the string of 1, which is very true, because behind the scenes you have to coerce both of these values to numbers. True is coerced to 1, and string is coerced to 1, the numbers, and then that is true. 1 is equal to 1. You don't have to know like why that's happening, but it does happen. So that's why just don't use it. Use the triple equal sign. Okay? So values can be coerced to Boolean values too. So this will be true. Any string that has length is truthy. Any string that has length is truthy. An empty string is false. When coercing a value to a Boolean, JavaScript uses rules to decide if a value should be coerced to true or false. Values coerced to true are called truthy. Values coerced to false are called falsy. Most values are truthy, right? This is an array, and this is an object, okay? High overview of what arrays and objects are, if you want to like know a little bit about what we'll be talking about next week. An array has brackets, and then everything inside of it is separated by commas, and arrays can hold any kind of data structure, any kind of data type. So this array has 1, 2, 3, 4 things in it, so its length is 4, and the last index is 3. Kind of sounds like strings, right? But this is also truthy, and this objects are just key value pairs. So the key of I is equal to the string and. The key of n is equal to the string object. We'll talk about this more next week, but just like that's what it looks like, okay? And these are actually easier to work with than they might look, okay? These are the only falsy values. Empty string, 0, null, undefined, not a number. I got them all. Nice. So a conditional expression works in an if statement, right? Like if the expression below evaluates to true, then the if block will run. In the if, right? Because 5 evaluates to truth. Evaluates to true if you coerce it into a Boolean, right? What if the conditional expression evaluates to a non-Boolean value? Yeah, I just showed you this with the 5. Right? This makes sense, right? Because any string with length is truthy, right? So if you just put a string with length, like apples, in an if statement, that, in the if, will always run. Yeah.
In that, like, where are you indicating that you're trying to coerce a value?
You're not. Whatever you put into the parentheses should evaluate to true or false. And anything could be coerced into a Boolean. So JavaScript is just going to coerce whatever you put into there into a Boolean. So like when you do like if this and this, like the and doesn't return true or false, it returns a value. So then the if statement actually takes that value and coerces that into a Boolean. Does that make sense? Because like the string apples, if you coerce it into a Boolean, would be true. So then this runs. If that was an empty string, you coerce that, that would be false. So then in the else would run. It's just, you guys will like understand this like sooner or later, especially after the workshop. So yeah, it implicitly coerces this into a Boolean. So you get yes and no, because 10 coerced into a Boolean is true, but 0 coerced into a Boolean is false. So here we get the yes, and here we get the no. Okay. So the bang operator coerces a value to a Boolean, and a value that's to a value that's a Boolean, but it's opposite of its truthiness. So like I said, bang true, bang ABC, bang 100, bang this array, bang this object is all false. Some people call it the not operator. I just say bang. Bang this, bang that. Yeah. When would you use that? So instead of writing like this is not equal to 0, this is not equal to true, this is not equal to this is not equal to that, you just do bang this, bang that, bang that, bang that. You know? It's like, so what I would usually do, like if I want a statement of, if I'm getting a value in from somewhere, I don't know what it is, but I want to put it into an if statement, you can just do double bang, and that will give you the value. Or you could do other bang, and you can get the opposite value. Whatever way works best for your mind. Okay? This is useful, the bang. Try and get into the habit of using it if you want to. If not, like whatever, it's up to you. I'm not going to tell you guys, you know what I mean? I'm not going to tell you guys to do something. But like, it's definitely easy to use. It's easy. It's like less stress on your fingers, you know? Because if you get carpal tunnel, it's kind of like the end of your career. And then you kind of have to find something else to do. Think about that like every day. But, you know, whatever. And you can use the double band too to explicitly coerce a value to a Boolean value that reflects its truthiness. Right? Double bang gives you its truthiness. One bang gives you the opposite of its truthiness. Okay? Cool. Yeah.
Similar, when we use the double bang, because if it's already evaluating, so that an if statement's already.
Well, you might not want to use that in an if statement. Like, let's say you just want to compare two pieces of data together to see if they're. I don't know. It's just like you might find something. I actually don't really use the double bang that much, but I had it before because it just makes things more clear. Just in case you don't know if this is going to be this, like just bang it, double bang it, and you'll get a true or a false thing. You know? Logical operators also coerce values to Boolean values. Right? 10 and 20. Both of those things are truthy, so you get true. I mean, you get inside the if. Right? Logical operator. So if you do this 10 and 0, 10 and 0, that isn't truthy, right? Because and returns the first falsy thing it finds, or the last truthy thing. But since there is a falsy thing, it returns the 0. So 10 and 0 is actually just 0. So if 0, not. 0 coerced is false. So we go into the else, 0 is false. Right? Yeah, nice. And returns the first falsy value or the last value if all are truthy. So here we have 10 and apples and 0 and no. We get 0 when we console log what it is there. Lucky and number and 7, we get 7. And like I said before, it kind of makes sense that this was to work like this, because and will be truthy and falsy depending on, like in if statements, this and this is true, right? So you have to check both things, right? You have to make sure that they're true, right? So you have to go through everything. And if you go through everything and you've never hit a falsy one, you just get the thing that you're on. But if you do hit a falsy one, you get the first thing it found. Because if it's all ands, then it's going to evaluate to false, right? But it will return the first value it finds, the first false value it finds. And the same thing can be said for or, except it's opposite. And that makes sense too, because or will return the first truthy value it finds and the last falsy value it finds. So no, undefined, happy, pumpkin, you get happy. Right? Because in an or statement, only one thing has to be true for the or for like everything inside the if block to run if you were using the ors in an if statement, right? So it just returns happy, and then in the if, it will coerce happy into a boolean. Here, it will return NaN, because NaN is falsy, and nothing before it is truthy, so we had to look for that one truthy value. Make sense? Good? So we talked about types, explicit coercion, implicit coercion, and coercing things into booleans and truthiness and stuff. And I kind of sped through the slides because like I did it with you. That was literally the same thing. How are you guys feeling about this? This is okay? This is good? Alright, take like 5 minutes, I guess. And then I'll slag out pairs. And we'll start the workshop.